Hello, everybody. This is Nick Totaro, Professor of Information Technologies and Computer Science, Lakeland Community College. Let's talk Caesar Cipher. But before we get into Caesar Cipher, let me break something down so we have a starting point here. There is a difference between a code, a secret code, and a cipher. A code is imagine a code book where you have one word that equals another word. So you might have a turtle being a tank. So in the military, they would often use code books to represent certain words. So like I said, they would say turtle in the code, and that would represent a tank. They may say an eagle, and that would represent a certain type of jet fighter. They can say slingshot, and that would represent maybe a certain type of firearm. Now, with a code, it has to be agreed upon. There's no way to really break the code unless somebody grabs a code book. It's not mathematically created. So codes are not what we're really concerned about in this video. We're concerned with a cipher. And what basically a cipher is you take a value and you run that value through some kind of arithmetic, and it comes out with another value. Now with a cipher, we should take the second value, run it through the arithmetic again, and get the original value. So you can see the value of having a cipher. You have a certain, what we call clear text. You run it through some algorithm, and then in that algorithm, we have some kind of key, and that's going to generate an encrypted value. We should be able to, make sense, to take that encrypted value, run it through the algorithm again with the key, and keys are very important. Not so much in this video, but keys become very important. But we run that encrypted value, run it through the algorithm with a key, and we get the clear text. One of the earliest ciphers is what they called the Caesar Cipher. Let's go up to Wikipedia as a quick little background about the Caesar Cipher, and then I'm going to run a little Python program to show you how this could potentially work. All right, so I'm up at Wikipedia, and this is a pretty good site. And a Caesar cipher is often referred to as a shift cipher. Basically, you have the plain text, A through Z, and you come up with a key. And the key basically shifts the values over. So in this particular example, the key appears to be 4. Or is it -4? Yeah, it appears. So here the clear text D becomes an A, E becomes a B, et cetera, and then it cycles through, and we can see that A becomes an X, B becomes a Y, and C, et cetera. Now, this was one of the earlier ciphers going back a few hundred years, few thousand years, but there's inherent problems with this type of cipher. One, the key. Both sides have to know what the key is. So if I'm sitting somewhere, say in Rome, and I decide to send a cipher to somebody, say in Germany, one, I send them the cipher, but I have to send them also the key. They need the key to decipher or de-encrypt the information. And that's a different process about how we share keys, about public versus private keys. But this is pretty rudimentary. It makes sense. I think most people see it. So one of the biggest inherent flaws with this is that it does require both sender and receiver to have the key. So how do you share the key? That's probably one of the most important questions when we talk about cryptography is how is that key shared? The other inherent problem with this is that it basically, with enough text, it's easily breakable. There are certain patterns that you can look for in words and in sentences. This is just a simple replacement. So over the course of time, with a long enough string, you can easily break up this code. For example, in the English alphabet, the letter E is very common. The word the is very common. So if I can look for certain patterns, I can then break the code. If I can establish, if you think about it, if I can establish the word the, I now know what the value of T is, what the value of H is, and what the value of E is. And there is a sequence of what alphabetic letters and their strength in a sentence may be. Let's go up to my little Python program here. And I'm going to do a little bit modified Caesar cipher. I'm not going to follow the approach of A is equal to 1, B is equal to 2, et cetera, et cetera. I'm going to first go to an ASCII table. And inside ASCII, ASCII is how characters are represented. I'm going to only be concerned with the ASCII value if I'm looking at the decimal. ASCII value 33 all the way up to 126. Those are what are referred to as printable characters. I don't want to make this too complex. So every printable character can be represented by ASCII as a decimal number. So the decimal value of 33 would be the exclamation point. The decimal value of 65 would be the uppercase A. The decimal value of 97 would be the lowercase a. So there's already numeric values assigned to these characters. So I decided when I wrote this code to not go into A is equal to 1, B is equal to 2. That makes sense because it's easy for us to understand, but I wanted to be a little more creative. I want to show you that, yeah, we already have a standard here. So in my cipher text, it's going to follow the same principles as all the other ciphers text. I'm going to be concerned with the ASCII value, and I'm going to shift it over. That's it. And then I'm going to see what is encrypted. So let's take a look at my small little Python program. So I have a couple functions here. This function main just basically is going to say, what are you trying to encrypt? What's the key? And up here is the actual Caesar cipher involved here. So it's going to take the text and it's going to take the offset. If you're not familiar with Python, that's okay. I'm not overly concerned with, but I want to show you how this is done with much bigger values. I think sometimes you see videos and they have very, very small values. But basically what this Python program does is it's going to shift over the ASCII value by whatever key I give it, and then convert that ASCII value back to a character. So it's going to take a character, it's going to find the numeric value of that character based upon simple ASCII, and then it's going to encrypt it, and then that's basically it. So let's run this program. And what I want encrypted is the quick brown fox jumped over the lazy dog, period. Now, you'll notice a couple things, or you should be noticing a couple things. We have a lot of spaces in there. That's interesting. We have the THE and THE in there, but yet one is uppercase THE, the other is lowercase THE. So let's see what happens. It's going to ask me for a key. I'm going to give it a key of 4. All right, not going to make this too complicated. I'm going to give it a key of 4. And here is the encrypted value. Now, here's where it can get broken very, very quickly. You will notice that there is a lot of dollar signs here, right? That's interesting. That could be an E or whatever. Maybe it's a space. Let's assume, I'm being silly here. Let's assume it's a space. So at every certain point, there's a space, and it looks like, okay, there's a 3-letter word. There's only so many 3-letter words. There's it's a 1, 2, 3, 4, 5-letter word. And here's where they would begin to break these. These can be broken very, very quickly. So let me remind you, there's generally 2 issues with the Caesar cipher. It's not used in cryptography, but it's the first cipher that we're usually taught in cryptography. Problem 1, you have to share the key. Somehow the sender and the receiver have to know the same key. How do you get the key from point A to point B? Big problem. Probably of all the problems, that's the massive problem. The second one is it's just a replacement cipher. It replaces one value with another value. Now, have they taken Caesar ciphers and improved upon them? Absolutely. fundamentally, most of our big ciphers now, the root of them, much more complex, is in the Caesar cipher. So this is the first one that is usually explained in cryptography, because you'll discover that, hey, we may not be shifting and we may change the key around, but you're basically replacing one value with another value. Let's do one more. Why not? Let's run it again. And this time we'll use a bigger number and we'll use the same sentence. And we're going to do an offset of 17. And there's the cipher, right? I set it up so, it would cycle around. When I got to the last printable characters, it would cycle and go to the beginning. But that's it. Now, if I was to create a very, very long text, this gets broken in a matter of seconds. So this is the Caesar cipher. Let's recap some things. This was an example of Caesar cipher. It is pretty much the root of cryptography going back many, many years. It's a simple replacement where we take a character, replace it with something else. So we take a character, run it through some kind of mathematical formula, and then that becomes the encrypted text. We should be able to, it'd be worthless if we couldn't, take the encrypted, reverse the arithmetic associated with it, as long as we have the key, and then we're able to read the clear text. If you look throughout history, a lot of the ciphers took this and just expanded upon it. So that being said, let's go and learn something.